Blockchain technology is essentially a decentralized digital ledger that records transactions across multiple computers in such a way that the registered entries cannot be altered retroactively. This revolutionary concept was first introduced to support Bitcoin, but its applications extend far beyond cryptocurrency. For instance, by 2025, it's estimated that blockchain will store about 10% of global GDP, demonstrating its growing importance in securing and managing data. One real world example is Walmart, which uses blockchain to track the supply chain of food products, ensuring safety and transparency from farm to shelf. This technology offers unprecedented security and efficiency by eliminating intermediaries and reducing fraud. As we delve deeper into this series, you'll see how blockchain is reshaping industries like finance, healthcare, and even voting systems. Next, let's explore the core components that make up a blockchain. The story of blockchain begins in 2008, when an anonymous person or group using the pseudonym Satoshi Nakamoto introduced Bitcoin. This was revolutionary because it was the first application of blockchain technology. Blockchain is essentially a decentralized ledger that records transactions across many computers so that any involved record cannot be altered retroactively without the alteration of all subsequent blocks. Interestingly, by 2021, there were over 9,000 different cryptocurrencies built on similar blockchain principles as Bitcoin. This innovation in digital currency and secure transaction processing laid the foundation for what we now see as a wide range of applications beyond just financial transactions. As we dive deeper into how this technology works, you'll see why it's considered one of the most transformative technologies of our time. At the heart of blockchain technology is the concept of blocks linked together in an unbreakable chain. Each block contains a batch of transactions and a unique code called a hash. When a new block is added to the chain, it includes not only its own hash, but also the hash from the previous block, creating a secure link. This means that altering any information within a block would change its hash, breaking the chain and immediately alerting the network to tampering. For example, Bitcoin's blockchain has over 700,000 blocks as of today, each one securely connected to the next. The computational power needed to alter even a single transaction is astronomical, making blockchain incredibly resistant to fraud. This robust security system ensures transparency and trust in every transaction. Now, let's dive into how these blocks are actually created and verified by the network participants. Decentralization is one of the core principles that make blockchain technology so powerful and unique. Unlike traditional systems where data is stored in centralized servers controlled by a single entity, like banks or governments, blockchains distribute information across a network of computers known as nodes. Each node has a copy of the entire ledger, ensuring no single point of failure. For example, Bitcoin's network consists of over 10,000 nodes worldwide, making it virtually impossible for any one party to manipulate the system. This decentralization also enhances security and transparency, as every transaction is verified by multiple parties before being added to the blockchain. Imagine if a hacker tried to alter a single record. They'd have to change that same record on all nodes simultaneously, which is practically unfeasible. As we move forward, understanding how this decentralized structure operates will be crucial for grasping the full potential of blockchain technology in various industries. Blockchain technology relies heavily on cryptographic techniques to ensure its security. One fundamental technique is hashing, which converts data of any size into a fixed-length string, typically through algorithms like SHA-256. For example, every transaction in Bitcoin uses this method to create a unique identifier that cannot be reversed or tampered with. Another key aspect is public key cryptography, where each user has a pair of keys, one public and one private. This system ensures secure communication and validation of transactions. For instance, Ethereum smart contracts use these cryptographic methods to execute code only when certain conditions are met securely. These robust security features make blockchain highly resistant to fraud and unauthorized access. Now, let's dive into how consensus mechanisms further enhance the reliability of this technology. Cryptocurrencies like Bitcoin and Ethereum are the most well-known applications of blockchain technology. Bitcoin, created in 2009 by an unknown individual using the pseudonym Satoshi Nakamoto, has become the gold standard for digital currencies. As of today, there are over 18 million Bitcoins in circulation with a market capitalization that often surpasses $500 billion. Ethereum, launched in 2015, introduced smart contracts and decentralized applications, expanding the functionality. Beyond just transactions, it currently holds the second largest market share among cryptocurrencies. These digital assets operate on blockchain networks, enabling secure and transparent peer-to-peer transactions without the need for traditional financial intermediaries like banks. Now that we've covered the basics of these cryptocurrencies, let's dive into how blockchain technology ensures their security and transparency in the next section. Smart contracts are essentially self-executing agreements with the terms directly written into code. They automatically enforce and execute transactions without any middlemen, making them incredibly efficient. For example, Ethereum is one of the most popular platforms for smart contracts, handling over 10 million transactions daily. These digital contracts can automate everything from insurance claims to supply chain management. In fact, a real-world application involves AXA's Fizzy service, which uses smart contracts to automatically process flight delay insurance payouts. This not only speeds up the process, but also reduces administrative costs significantly. By automating these processes, blockchain technology ensures transparency and security in every transaction. Next, we'll dive into how blockchain can revolutionize voting systems, ensuring fairness and integrity in elections. Blockchain technology isn't just about cryptocurrencies like Bitcoin. It has a wide range of applications that can revolutionize various industries. For example, in supply chain management, companies like Walmart use blockchain to track food products from farm to store shelves, ensuring safety and transparency. This system has reduced the time it takes to trace the origin of a product from days to just seconds. Another area is digital identity verification, where governments and tech firms are exploring how blockchain can securely manage personal data. Estonia, for instance, uses blockchain technology to secure its citizens' health records, making them tamper-proof and accessible only with proper authorization. These examples show that blockchain's potential extends far beyond finance, offering robust solutions for security and transparency in diverse sectors. Next, we'll dive into how blockchain can impact the healthcare industry. Blockchain technology is revolutionizing supply chain management by enhancing transparency and efficiency. For instance, Walmart uses blockchain to track its food products from farm to store, reducing the time needed to trace the origin of a product from days to just seconds. This kind of real-time tracking not only speeds up processes, but also significantly reduces the risk of contamination outbreaks. A study by IBM found that 95% of businesses believe that transparency in their supply chain is crucial for building consumer trust. By using blockchain, companies can provide consumers with detailed information about the journey of a product from its source to the shelf. This level of traceability and accountability not only boosts customer confidence, but also helps in streamlining operations by identifying inefficiencies quickly. Next, let's explore how blockchain is transforming financial transactions. Blockchain technology is making significant strides in the healthcare sector, particularly in managing medical records. For instance, the Estonian eHealth Foundation uses blockchain to secure patient data, ensuring that over 1 million citizens have access to tamper-proof health records. This not only enhances privacy, but also streamlines record sharing between healthcare providers. In the United States, a study by IBM found that 16% of surveyed healthcare executives were already implementing blockchain solutions in their organizations. By using blockchain, hospitals and clinics can reduce administrative costs and improve patient care through more efficient data management. For example, it allows doctors to access a patient's entire medical history instantly, leading to better informed decisions. As we see these real-world applications, the potential for blockchain in healthcare is immense, setting the stage for even more innovative uses down the line. Next, let's explore how blockchain can revolutionize the financial industry. Blockchain technology is not without its challenges. One significant issue is scalability. For instance, Bitcoin can process around 7 transactions per second, compared to Visa's 24,000 transactions per second. This limitation hinders blockchain's widespread adoption in high-volume transaction environments. Another challenge is energy consumption. The proof-of-work mechanism, used by many blockchains, consumes vast amounts of electricity. For example, the Bitcoin network uses as much energy annually as the entire country of Argentina. These challenges highlight the need for technological advancements and alternative consensus mechanisms like proof-of-stake to make blockchain more efficient and sustainable. As we delve deeper into these issues, it's clear that overcoming them is crucial for blockchain's future success. Blockchain technology is transforming how we manage and trade energy. In places like Germany, blockchain platforms are facilitating peer-to-peer energy trading among households, allowing solar panel owners to sell excess electricity directly to neighbors. This not only reduces reliance on centralized grids, but also cuts down transaction costs by up to 50%. Another example comes from the UK, where Electron, a blockchain-based platform, is enabling more efficient and transparent Management of renewable energy sources. By providing real-time tracking of energy production and consumption, it helps in balancing supply and demand seamlessly. These innovations highlight how blockchain can enhance transparency, efficiency, and sustainability in the energy sector. Next, we'll dive into how blockchain is revolutionizing the financial services industry. Blockchain technology is revolutionizing financial services by streamlining processes and enhancing security. For instance, in banking, blockchain can reduce transaction times from days to minutes, significantly lowering costs. According to a report by Accenture, banks could save up to $10 billion annually by 2025 through blockchain applications. In insurance, smart contracts on the blockchain automate claims processing, reducing fraud and speeding up payouts. For example, Swiss Re has already implemented blockchain for reinsurance transactions, cutting down settlement times from weeks to hours. This kind of efficiency is just the beginning of how blockchain can transform financial services. As we move forward, expect more innovations that will reshape not only banking and insurance, but also other areas within finance. Next, let's explore how blockchain is changing the landscape of supply chain management. The regulatory environment for blockchain technology is complex and evolving rapidly. Countries around the world are taking different approaches to regulate this emerging field. For example, in China, all cryptocurrency trading was banned in 2017, while countries like Switzerland and Malta have become hubs for blockchain innovation by offering a more welcoming regulatory framework. The United States has taken a piecemeal approach with various agencies like the SEC, CFTC, and IRS, each tackling different aspects of regulation. In Europe, the European Union's Markets in Crypto Assets (MiCA) regulation is set to create a comprehensive legal framework for crypto assets by 2024. These diverse regulatory landscapes reflect the global uncertainty and evolving nature of blockchain technology. As regulations continue to shape this space, it will be crucial for businesses and individuals to stay informed about the latest developments in their regions. The future of blockchain technology is incredibly promising. By 2025, the global blockchain market size is expected to reach $39.7 billion, showcasing its rapid growth and widespread adoption across various industries. For instance, in healthcare, blockchain can ensure secure sharing of medical records, enhancing patient care while maintaining privacy. In finance, it's already revolutionizing transactions with faster, more secure methods like Ripple for cross-border payments. Imagine a world where every transaction is transparent yet private, reducing fraud and increasing trust. As we move forward, the integration of artificial intelligence and blockchain could lead to even smarter systems that automate complex processes. With these advancements on the horizon, it's clear that blockchain isn't just a fleeting trend but a fundamental shift in how we interact digitally. Next up, let's explore some real-world applications of this technology. Blockchain technology is revolutionizing various sectors, and education is no exception. One of its most promising applications is secure credential verification. For instance, MIT has already issued over 4,000 digital diplomas using blockchain, ensuring that credentials are tamper-proof and easily verifiable. This not only streamlines the process for educational institutions, but also provides students with a secure way to showcase their achievements. Imagine being able to instantly verify a candidate's degree or certification without having to contact the issuing institution. This could significantly speed up hiring processes and reduce fraud. In fact, a study by IBM found that 70% of HR managers believe blockchain can help combat fake degrees. As we move forward, it's clear that blockchain will play an increasingly important role in making educational credentials more secure and accessible. Next, let's explore how blockchain is transforming the world of finance. Blockchain technology has the potential to revolutionize voting systems by enhancing security and transparency. For instance, in 2018, West Virginia piloted a mobile voting system using blockchain for military personnel stationed overseas. This not only increased voter turnout, but also ensured that votes could be cast securely without fear of tampering. The immutable nature of blockchain means once a vote is recorded on the chain, it cannot be altered or deleted significantly, reducing the risk of fraud. Estonia has been a pioneer in digital governance and uses blockchain to secure its national identity card system, which also supports online voting for elections. This technology ensures that every vote can be traced back to an individual without revealing their choice, maintaining privacy while ensuring accountability. By integrating blockchain into voting systems, we could see more secure, transparent, and efficient democratic processes worldwide. Next, let's explore how blockchain is transforming the supply chain industry. Blockchain technology is revolutionizing various sectors, and real estate is no exception. One of its most promising applications is in property title management. In fact, countries like Sweden have already piloted blockchain-based land registries to streamline transactions and reduce fraud. By using smart contracts on the blockchain, property transfers can be automated, eliminating the need for intermediaries like lawyers or notaries. This not only speeds up the process, but also significantly reduces costs. For instance, a study by IBM showed that blockchain could save up to 30% in transaction fees. Additionally, it enhances transparency and security, as every transaction is recorded immutably on the ledger. As we can see, these improvements make real estate transactions more efficient and reliable. Next, let's explore how blockchain is reshaping the financial industry. Blockchain technology is revolutionizing the gaming industry by giving players true ownership over their digital assets. Imagine owning a rare sword in a game like Crypto Blades. Thanks to blockchain, this weapon isn't just data on a server. It's a unique token you can trade or sell on marketplaces outside the game itself. This concept of non-fungible tokens, or NFT, has become incredibly popular. In fact, the NFT gaming market is projected to reach $40 billion by 2028. Games like Axie Infinity have already shown how blockchain can create economies where players earn real money from in-game activities and asset trading. This shift not only empowers gamers, but also decentralizes control over virtual worlds. As we move forward, the integration of blockchain could make gaming more interactive and rewarding than ever before, setting the stage for even more innovative applications down the line. So we've covered quite a bit about blockchain technology, from its foundational concept as a decentralized ledger to its applications in industries like finance and healthcare. It's clear that blockchain is more than just the tech behind cryptocurrencies. For instance, over 80% of executives believe that blockchain will significantly impact their business within the next 5 years. And with examples like Walmart using blockchain for food safety tracking, reducing contamination incidents by up to 95%, we can see its practical benefits. The key takeaway is that blockchain offers a secure, transparent way to manage transactions and data without needing intermediaries. As we wrap up this journey through blockchain technology, I encourage you to explore more on your own. Dive into specific use cases or the tech behind smart contracts. There's so much to discover in this transformative field. Stay curious and keep learning.